In higher level mathematics, one of the key skills you have to be able to do is factorising functions, specifically quadratics, so functions with x squared as their highest power. Now at National 5 level we covered 3 key ways of doing this. We covered common factor, we covered difference of two squares, and we covered trinomial factorisation. One more key way of doing this that we're going to cover in this video is what's called the completed square form, so putting a quadratic in that. Now completed square form has the same general format, and it looks something along the lines of this: a bracket x plus b squared plus c. It's something written in this format. Now there's 2 different levels of difficulty with this, and that's when we've got to factorise something. So let's say something along the lines of x squared plus 4x plus 1, and when we've got to factorise something that's maybe of the format 2x squared minus 8x plus 3. The difference in difficulty comes from the coefficient of the x squared, but it's not hugely more difficult. It just adds an extra step or 2 into our calculation so that we've got a couple of extra things we need to do. And you can imagine one like this where there's a coefficient of x squared is 1, your a just becomes 1. So this one here we'd put into the format of just simply x plus b squared plus c. The 2x squared minus 8x plus 3, because there's a coefficient of the x squared, we're going to end up with something outside the bracket, because here in the bracket our coefficient of x that we want is simply 1. So let's bring the idea in with a straightforward example to begin with. Let's imagine we're going to do that one that was x squared plus 4x plus 1, and I want to put it in the completed square form. Now when we're doing completed square form, the same first step happens every time. We focus on this part here. The plus 1 will come into play in a few minutes, but we don't focus on that if we're looking to factorise this. Now what we want is something of the form x plus b squared. So what we have to do is start by writing a bracket of x plus something, and we know it's a plus because there's a plus here. If this is a minus, this would be x minus b squared. This sign depends on the sign here. And what we do is we look at the coefficient of the x and we half it. So we get x plus 2 squared. And that's where the plus 1 comes back in. But there's an issue here. If we've got x plus 2 and we square it, we end up getting x squared plus 4x plus an additional 4. So we don't get back to the x squared plus 4x. So this is where we have to introduce what we're going to call a correction factor. So we have to subtract something to counteract this. And the easy way to think about it is your correction factor. What you do is you take away this number here, squared. So we take away 2 squared in this case. Now ignore the sign. Because it's a square number here, the sign will correct itself and it'll just end up being take away. Because we've got this now, what we can then do is correct it. So keep the bracket the same, x plus 2 squared. We've then got plus 1, and then we're taking away the 2 squared. We've taken away 4. So what I'm now then able to do is write it. So I've got x plus 2 all squared, take away 3. Now if we were to do a check and multiply this out, I would get x plus 2 squared, so I'd get x squared plus 4x plus 4, and then I'd have to subtract 3. And if I simplified this, I would get x squared plus 4x plus 1. Lo and behold, our original expression. So this is it now in its completed square form. When we're doing it, these are the key steps we have to follow. So we focus on this part. We have to remember a correction factor to fix it for when we multiply it back out. And then we have to make sure we just simplify that at the end. So simplify the numbers as much as we can. Now, adding a coefficient to x squared adds an extra step or 2 that we have to do, but it's not a hugely different one. And there's also 2 methods we can do for this. I'm going to talk you through both of them. You pick the one which is easiest to you. So let's imagine for both cases, I'm going to do 2x squared, take away 8x plus 2. Now, if you think about the way we generally want it, we want it as a bracket x plus b squared plus c. We want it to look like this. So the first thing we have to do is get rid of the coefficient of x. So the first thing you do again is you focus on this section here. And you start by taking out a common factor so that your coefficient of x squared is 1. And in this case, that would be a common factor of that section of 2. So I get 2 bracket x squared minus 4x. We've then got the plus 2 at the end there. The next thing I then focus on is what is within here. And what I do to that is I do the exact same as I did before. I put it in the bracket form and then I correct it. So in this case, I'd have it as x minus 2 in a bracket, because remember, we look at half the value here, squared, but then I've got to take away my correction factor. I've got to then take away this number here squared. Now, this is where the confusion might come in with some people, so I'm going to make sure I explain this clearly. This part here just relates to this part here that's highlighted. We've still got the 2 outside, we still have the plus 2. So I've got to then make sure I put this whole part in a bracket and multiply it by the 2 that was on the outside, and then add on the 2 at the end. Once I've done this, I'm actually then able to start simplifying things down. Because what I can do is look in here and simplify it to be 2 bracket x minus 2 squared, take away 4, close the bracket, and then plus 2. And then I can start to simplify by multiplying out the bracket and getting the constants together. So multiply this whole bracket out by 2, and I get 2 bracket x minus 2 squared minus 8, because I've got 2 take away the 4, 2 times the 4, sorry, take away the 8, and then plus the 2 at the end. And then I just simplify these constants here, and I get 2 bracket x minus 2 squared, take away 6. Here's the check. If we want to check it at this point, we multiply it out, and I hope I get back to 2x squared minus 8x plus 2. So let's do that. So multiply out the x minus 2 squared, so I've got 2 bracket x squared minus 4x plus 4, and then I subtract 6 after it. Then multiply the bracket out by 2, I get 2x squared minus 8x plus 8 minus 6, and then I simplify it. I get 2x squared minus the 8x plus 2. Lo and behold, I'm back to my original expression. I'm back to where I started. So this, you can do next to it if you want, and have it as your check. Make sure you've done it right. So this is one way of doing it. Now another way of factorizing something like this is take your 2x squared minus 8x plus 2, and we want to put it in this form. Remember, a bracket x plus b all squared plus c. Well, let's imagine we multiply out this generic equation here. I'd end up with a bracket x squared plus 2bx plus b squared, and then a plus c at the end. If I then multiply this bracket out by the a, I get ax squared plus 2abx plus ab squared plus c. Now, if we're looking at that, that looks like a bit of a complex expression, but it's actually just a quadratic. You've got your x squared term here, you've got your x term here, and you've got your constant term here at the end. Yes, it's made up of a couple of little terms, but these are all constants. There's no x dependence in here at all. So this is just your constant term right at the end of the expression. What we're able to do then is take this whole thing and equate the different coefficients to the coefficients here. So I could look at the ax squared and say, right, so ax squared, I want that to be 2x squared. I can then say that a equals 2. I want the 2ab to be equal to the coefficient of the x, so I then want 2ab equal to negative 8. And I want the ab squared plus c equal to my constant at the end. So I want my ab squared plus c equal to the 2 at the end. And what I can then do is start solving these three equations one at a time for the a, the b, and the c. So I know a is 2, great, I can solve that straight away. I then substitute in here, and I'll 2 times 2 times b is equal to negative 8. So 4b is negative 8, which means that b has to equal negative 2. I now know a and b, and I can substitute them in here. So I know that's going to be 2 times negative 2 squared plus c, and I know that's going to equal 2. Negative 2 squared is 4, times 2 is 8, so I then know that c plus 8 equals 2. Solve that, and I get c equals negative 6. What I can then do is just write my expression using the a, b, and c I've just solved. So I can then write it as 2 bracket x minus 2 all squared, take away the 6. And that there is how I want it. And again, I've got my check I can do at this point just to make sure that I've got it right. So I'd expand the bracket, so I'd have 2 bracket x squared minus 4x plus 4, take away 6, multiply the bracket, and I get 2x squared minus 8x plus 8, take away 6, simplify it, and I get 2x squared minus 8x plus 2, my original expression. So that's two different techniques for doing the exact same thing that I've now got. Whichever one resounds with you the best, use it. Whether it's this technique or whether it's the previous one, use whichever one clicks with you the easiest, because they'll both gain you all the marks as long as you show all of your work in. So as long as you show expanding it to get to here, equating all of your coefficients, and most importantly, writing your final answer out, regardless of whether the x squared's coefficient is an even number, an odd number, or a positive or a negative number. This will work as long as you follow those steps.